Let's use the second derivative test to find where this function is concave up. So I'm going to start off by making what's called a sign chart to organize my information. First, we need to make our intervals, and to do that, we need to find the points of inflection of our function. To do that, we find our second derivative, set it equal to 0, and solve for x. Now we know that since there's one point of inflection, there's going to be two intervals we have to consider. We take our point of inflection at x equals minus 1/3, and we cut the number line at this point into two intervals. This is because the point of inflection tells us when the concavity of a function changes. Now we need a point in each of these intervals to test the sign of f double prime in that interval. And it can be any number in this interval you want. So here I'm going to pick -1, and here I'm going to pick 0. Now we find the sign of f double prime at these points. We see that f prime of -1 is -4, which is negative, so I'm going to put that in my chart. And we see f prime of 0 is +2, which is positive, so I'll put that in my chart. Since f double prime is negative in this interval, we can say that f is concave down on this interval. Similarly, knowing that f double prime is positive in this interval lets us say that f is concave up on the interval. To answer the original question, the interval where f is concave up is from -1/3 to infinity. And that's how I use the second derivative test.